Our lecture number 7, unit number 1, solid state physics. Okay, in this lecture we will see why 5-fold or 7-fold rotation symmetry does not exist. Okay, we will prove it by analytical method. Okay, so we'll see one picture related to it, and we will draw one figure, and on the basis of that figure we'll prove 5-fold or 7-fold rotation symmetry does not exist. Okay, so consider these are 4 lattice points, 1 2 3 4. They are arranged in a row. Okay, suppose these 4 lattice points are present in a plane. Okay, we will label as x, p, q, y. Okay, and suppose the distance between these lattice points is a. Okay, so a is nothing but the translation vector. When we translate the lattice point x to p, so a is the translation vector. When we translate the lattice point p to q, a is the translation vector. When we translate the lattice point q to y, a is the translation vector. Okay, now we'll prove why 5-fold or 7-fold rotation symmetry does not exist. For that, we have to consider the system possesses n-fold rotation. Okay, we'll consider that the system possesses n-fold rotation. Suppose we'll rotate this vector px. Okay, this vector px through an angle phi n, suppose. Okay, similarly clockwise, we have rotated it clockwise. Similarly, we will rotate this vector qy in anti-clockwise direction via same angle phi n. Okay, then we will get another lattice point here. So this will be the new position of lattice point p. Okay, this is the new lattice points. Okay, let that new lattice point is p1. Okay, for p, and this new lattice point is q1 for q, and we have rotated this vector through an angle phi n. Okay, in clockwise direction, and we have rotated this qy in anti-clockwise direction through an angle phi n. Okay, and we'll get new lattice points p1 and qn. Suppose the translation of lattice point p from p to p1 is same a, and translation from lattice point q to q1 is same a. Okay, but we have to remember that when we shift the lattice points, okay, from p to p1 and q to q1, the lattice environment should not change. Okay, if there is a existence of symmetry, then lattice environment should not be changed. Okay, so nearby p1 there is one more lattice point, and nearby q1 there is one more lattice point, so that surrounding should not be changed. Okay, we'll consider these lattice points as r and s. So we will get a new row of lattice points. Okay, which row? p1 r s q1. Okay, so we will get 4 new lattice points, p1 r s q1. Okay, with the help of rotation and translation symmetry. Okay, now we will draw one perpendicular from p to r, okay, and q to s. This is the perpendicular we have drawn, 2 perpendiculars from p to r and q to s. Okay, now we have to remember the geometry. These 2 lines xy and this p1 q1, these 2 lines are parallel. Okay, suppose these 2 lines are parallel and they are visualizing as parallel lines. These 2 lines are parallel, and if we consider this p1p as a transversal, so we know that the property of parallel lines. Okay, so these 2 lines are parallel and p1p is the transversal. So if this angle is phi n, so this angle is also phi n. Okay, because of these angles are the alternate angles. Okay, according to the theorem of alternate angles, these 2 lines are parallel. Okay, and this is the transversal. Okay, if this angle is phi n, this angle is also phi n. Similarly, these 2 lines are parallel, and if q1 is transversal, so this angle is phi n, so this angle is also phi n. because both angles are alternate angles and alternate angles are equal, phi n. So this angle is also phi n. If this angle is phi n, this angle is also phi n according to the theorem of alternative angles, okay, by the property of parallel lines. Okay, now if this PRSQ is the rectangle, and if this is the A, PQ is A, side PQ is A, then RS is also A. Okay, then RS is also A. Okay, now we have to find out P1R and SQ1, Q1S. We know that in the triangle P1RP, this is right angle triangle, and this is an angle phi n, and this is the hypotenuse P1, because the opposite side of 90-degree angle is called hypotenuse. P1P is the hypotenuse, that is A, and this angle is phi n. Okay, if I want to find out this P1R, then we have to remember the trigonometry. Okay, we will find out the cosine of phi n. So cos phi n is adjacent upon hypotenuse. Cos phi n is adjacent upon hypotenuse. Adjacent side is P1R, hypotenuse is A. So cos phi n is P1R divided by A. So P1R is A cos phi n. Similar, see, very simple. We have used geometry and trigonometry. So P1R is A cos phi n. Similarly, in this triangle SQ1Q, this is the angle phi n. If I want to find out Q1S, then I have to use the geometry. I have to use the trigonometry. So cosine of angle I have to use, because in cosine of angle formula there should be adjacent side. Cos phi n is nothing but adjacent side Q1 upon hypotenuse. Hypotenuse is A. So cos phi n is equal to Q1S divided by A. So that QS is nothing but A cos phi n. A cos phi n. So now we have found out P1R is A cos phi n, Q1S is also A cos phi n, and we know the RS because this is a rectangle. If PQ is A, then RS is also A. Okay, so now I will tell you one important thing. Okay, when we shift the lattice point from P1 to Q, okay, then we have to do some translations. Okay, we have to go from P1 to R to S, and S to Q1. If I want to reach from P1 to Q1, so how many translations we have to do, we don't know. Suppose from going from P1 to Q1, suppose we have to do M translation. So M into translation vector. So the length of P1 Q1 must be equal to what? Must be equal to MA. M means integer, A is translation. M, okay, multiplication, okay, factor. M into A. M is integer. Okay, so P1 Q1 is nothing but M into A, but we know that P1 Q1 is nothing but P1R plus RS plus SQ. Okay, and we have considered initially this system possesses n-fold of rotation. So n-fold rotation through an angle phi n is equal to 360 by n. We know this formula. This formula I have already told you in the lecture of symmetry and symmetry operation. Okay, rotation angle is nothing but phi n is equal to 360 divided by n. Okay, n means number of rotation. Okay, n means number of fold. If n is equal to 1, that is 1 fold symmetry. M n is equal to 2 fold symmetry. Okay, number of fold, and phi n is rotation angle. Okay, so from this diagram and from this whole figure, we have found out P1 Q1 is equal to P1R plus RS plus SQ1 and is equal to nothing but, we don't know the how many translations are required from going from point P1 to Q1. Suppose M translations are required, so M into A. So with this help of this formula, we will find out whether the 5-fold or 7-fold rotation axis or rotation symmetry exists or not. Okay, so this is the brief summary and brief figure. Okay, we have to find out P1 Q1. Okay, so अभी मैंने जितना यहाँ पर बताया, okay, just I have quoted onto the slide. So consider lattice points x, p, q, y. Okay, we have considered that x, p, q, y. Okay, suppose the system possesses n-fold rotation through an angle phi n. Okay, we have considered that. Okay, and we have also considered the vectors px and qy rotate through an angle phi n. Okay, just look at the figure. Vector px and qy, px is we rotate clockwise direction through an angle phi n, and qy rotates in anti-clockwise direction through an angle phi n. So the value of angle phi n, we know the formula, phi n is equal to 360 by n, okay, degree. If I want to find out n from here, so n is nothing but 360 by phi n. Okay, so we have considered that the vector px is rotated in clockwise direction, qy is rotates in anti-clockwise direction. Okay, then therefore the position of new lattice points, okay, the position of new lattice points are p1 r s q1, okay, so that the lattice surrounding should not be changed. A be the translation vector. Okay, we have considered that A is translation vector, so pp1 is equal to qq1 is equal to A. We know that. Just look at the figure. pp1 and qq1 is A, and rs is equal to pq is also A. Very simple. Okay, just I have shown the diagram. Okay, with the help of diagram I have quoted some sentences on the slides. So pp1 is equal to qq1 is equal to translation vector A, pq is equal to rs, okay, equal to A, that is also translation vector. Now we have considered two triangles. In triangle PRP1, just look at the figures. In triangle P1R, yeah, PRP1, PP1R, cos phi is nothing but adjacent side P1R upon hypotenuse. Hypotenuse is PP1. Just look at that, I have already told you. Okay, in triangle PRP1, cos phi n is equal to P1R upon pp1, but pp1 is hypotenuse, that is A. So with the help of these we can find out p1r is nothing but A cos phi n. This is the equation number 2. Similarly in another right angle triangle, okay, which right angle triangle I am talking about? This right angle triangle q1sq. okay, in this also we can find out the cos phi n. Cos phi n is adjacent side is q1s and hypotenuse is qq1. Similarly, okay, similarly in triangle QSQ1, cos phi n is equal to Q1S divided by QQ1, Q1S divided by A, QQ1 means A, so Q1 is nothing but A cos phi n. So we have found out P1R is A cos phi n and Q1S is also A cos phi n, and we know the RS is A, okay, but when we translate the point, from P1 to Q1, so length of P1 must be equal to the integral multiple of translation vector, that we have already told you in the first slide. Okay, when we translate from lattice point P1 to Q1, okay, then the length of P1 Q1 should be equal to the integral multiple of A. Very simple, integral multiple of A. So therefore P1 Q1 is equal to M into A. M is integer, M is 0, 1, 2, 3, okay, whatever may be. Now P1 Q1 from the figure, you know that P1 Q1 is nothing but P1R plus RS plus SQ1. Just look at the figure. Very simple. PQ1, the length of PQ1 means P1R plus RS plus SQ1. Very simple. So that is P1 Q1 is equal to P1R plus RS plus SQ1 is equal to MA. Now P1R is A cos phi n, RS is A and Q1S is A cos phi n from the figure, and this is equal to MA. Now A cos phi n, okay, now I have quoted same steps here. A cos phi n plus A cos phi n is equal to MA. Now A cos phi n, okay, A cos phi n, 2A cos phi n, very simple. A plus A, twice A, B plus B, twice B. So A cos phi n plus A cos phi n, that is twice A cos phi n plus A is equal to MA. Now A is here in first term, A is here in second term also, so A should be common. So I have taken A common in the bracket, A common, after taking A common, okay, in the bracket 2 cos phi n plus 1. Now A is here in left hand side and A is here in right hand side. If I take A to that side, then it would be in the denominator, so A will be cancelled, okay, A is cancelled out, okay, then we will remain with 2 cos phi n plus 1 is equal to M. Now I will shift 1 to that side, so I will get 2 cos phi n is equal to m minus 1. 2 2 cos phi n is equal to m minus 1. Now I have to find out the cos phi n. So cos phi n, I will take 2 to that side, so 2 will come into the denominator, then cos phi n is equal to m minus 1 divided by 2. So I will get this formula. So we will get the formula cos phi n is equal to m minus 1 divided by 2. Okay, so m is integer. If we subtract 1 from the integer, we will get new integer. If suppose m is 4 and we subtract 1, then we will get 3. 3 is also integer. So m is old integer, n is new integer. So in place of m minus 1, we will keep n. So we will get the formula cos phi n is equal to n by 2. So with the help of this formula, we can find out why 5-fold symmetry doesn't exist. Okay, so cos phi n is equal to n divided by 2. Okay, so you know that minimum value of cos phi n is nothing but minus 1, and maximum value of cos phi n is 1. Minimum value of cos phi n is minus 1, maximum value of cos phi n is 1. Okay, if we will keep in place of cos phi n minus 1, okay, if you put minus 1 here, okay, minus 1 here, then the value of n will be, for corresponding value of n will be minus 2. If I will put cos phi in place of cos phi n minus 1, here minus 1, so n will be minus 2. If I will put in place of cos phi n 1, then n will be 2. So minimum value of, corresponding minimum value of n is minus 2 and maximum value is 2, and minimum value of cos phi n is minus 1 and maximum value is 1. So we will make one table, okay, this table, and minimum value of n is minus 2 and maximum value of n is 2. In between that, minus 1, 0, 1. Okay, there will be 3 values in between that. Minimum value minus 2, maximum value 2. In between that, will get minus 1, 0 and 1. Minus 1, 0 and 1 are present in between those values. Okay, minimum value minus 2 and maximum value 2. Okay, so total values of n will be 5 values: minus 2, minus 1, 0, 1 and 2. Okay, with the help of this formula, if I divide this by 2, okay, then we will get n by 2. Divide by 2 this, n divided by 2, minus 1. Minus 1 divided by 2, minus 1 by 2. 0 divided by 2, 0. 1 divided by 2, 1 by 2. And 2 divided by 2, 1. So we will get these values of n by 2. Okay, n by 2 means cos phi n. Cos phi n is nothing but n by 2. N by 2 means cos phi n. So what will be the value of cos phi n? Cos phi n value n by 2, when n by 2 is minus 1, cos phi n is also minus 1. When n by 2 is, n by 2 value of n by 2 is minus 1 by 2, cos phi n is also minus 1 by 2. If the value of n by 2 is 0, cos phi n is also 0. When the value of n by 2 is 1 by 2, cos phi n is also 1 by 2. Okay, when the value of n by 2 is 1, cos phi n is also 1 from this formula. Okay, but we know that according to the trigonometry, okay, the value of cos phi n is minus 1, okay, at the angle 180 degree. Okay, the value of cos phi n minus 1 value कब होती है 180 degree पे. Okay, the value of cos phi n minus 1 at 180 degree. So phi n is 180 degree. If I will put this formula comes from first slide. We know that in first slide I will show you this formula. Okay, so this formula, this rotation angle is 360 divided by n. Okay, when I will shift n there, then phi n here, so n is nothing but 360 divided by phi n. Okay, this formula comes from the first slide. Okay, so this is n is equal to 360 divided by phi n. When phi n is 180, so 360 divided by 182, we will get n is equal to 2, means two-fold rotation symmetry. Okay, minus 1 by 2, cos phi n is minus 1 by 2. So cos phi n 1 by 2 minus 1 by 2 कब होता है? At which angle? At 120 degree. That is 2 pi by 3. Cos 2 pi by 3 is minus 1 by 2. Cos 2 pi by 3 is minus 1 by 2, means 120 degree. If we keep 120 degree here in place of phi n, so I will get 3. N is equal to 3. 120. 360 divided by 120, 3. N is equal to 3, means threefold rotation symmetry. Okay, now third one, cos phi n, the value of cos phi n is 0. At which angle? 90 degree, because cos 90 is 0. Okay, then if I will keep 90 degree here in place of phi n, 360 divided by 90 we will get 4. So n is equal to 4. Four-fold rotation symmetry. Now cos phi n is equal to 1 by 2. At which angle the value of cos phi n is 1 by 2, or half 60 degree angle? Cos 60 is nothing but 1 by 2. So in place of phi n I will keep 60. So 360 divided by 60, that is nothing but 6. Okay, so 6-fold rotation symmetry. Now 1, last value, cos phi n is 1. So at which angle the value of cos phi n is 1? That is 360 degree. So 360 divided by 360. So we will get n is equal to 1. So we are getting the 5 values of n is equal to 1, 2, 3, 4 and 6, but we are not getting the value of n 5 or 7. We are getting the value of n 1, 2, 3, 4 and 6, but we are not getting the value of 5 and 7. So mathematically it is proved that there is no existence of 5-fold or 7-fold symmetry in the crystal. Okay, the 7-fold or 5-fold symmetry does not exist because we are not getting the value 5 or 7 here in the table. Okay, so analytically we proved that 5-fold or 7-fold rotation axis or rotational symmetry does not exist the crystal. So this is the mathematical or analytical treatment or analytical method to show why 5-fold or 7-fold symmetry doesn't exist. Thank you.